In the last video, you guys learned how to write the equation for a line given some information. In this video, we're going to talk about a second method that you guys can use to accomplish the same thing. So as I wrote here, we're going to be talking about writing equations in point-slope form. This is going to be doing the same thing as the solve for b method. That's what we did in the last video, where you basically plugged in your x and y, got b, rewrote the equation. Either method is totally fine. They accomplish the same goals. I want you to hear it out though and listen to this video, try it both ways, and then from there you can make a decision. Some kids like this way better, other kids prefer the first method. They're both perfectly good ways of doing it. So far, when we've talked about lines, we've wanted it in slope-intercept form. Slope-intercept form is y equals mx plus b. And if you didn't already realize this, the reason it's called slope-intercept form is because you can see the slope and the y-intercept by just looking at it. It's named appropriately. Well, our second form right here is called point-slope form. To use point-slope form, you need, as the name might imply, a point and a slope. Just any random point, intercept or not, so you need a point and a slope. The variables you're going to be plugging into in this equation are going to be the x1, y1, and m. So plug in for x1, y1, and m, then solve for y. So this formula may look a little more complicated than our old example, but once you get used to these, they really go super fast. You just plug them in the formula, you do it, and it's really very manageable. So I want to actually try out the same two problems that we did in the last video. I accidentally erased it already, but I reworked them. That way we can see, and I can show you that it still works. So we did this problem already. They gave us a slope, they gave us points. And what we did before is we wrote our slope in there, then we solved for b by plugged in our point, solved for b, and wrote our equation. If we wanted to, method 2 we could use is our point-slope form. So if we're using point-slope form, this is kind of like our go-to formula for writing the equation of a line. I'm going to plug in my x1 and my y1 from my points. So that 4, 1 up here, we got our x1, we got our y1. The y stays in the equation, so it's a y minus, y1 was a 1, equals, my slope is 1/2, so I get 1/2 parentheses x minus, and my x1, my x coordinate, is a 4. So I'm going to plug a 4 right in there. And this is a perfectly fine equation. It's great. It's just like that. However, on a multiple choice test, or just in terms of using it in a problem, it's not all that convenient to have it written in that form. So what we're going to do is distribute and get y by itself. So we want to get rid of our parentheses. We get y minus 1 equals 1/2 x, and 1/2 times -4 is -2. We're going to add 1 on both sides. And when we do that, we get y equals 1/2 x minus 1. Exact same equation we got up here. You can see that the answers match. So it's a matter of preference here. Yeah, it's a little nicer in the sense that here we had to do all that work where we plugged it in to solve for b. That was kind of annoying to have to do that. Here, you just plug them straight in. The difference is you have to distribute the stuff at the end. Both accomplish the same thing, but it's really a matter of preference. I want to do one more problem, and I'll choose the other one from our last video. Again, here's a reworked example. It's the problem that we did before, written slightly differently. And let's do this now with our new point-slope formula. So according to point-slope, our formula says it's going to be y minus y1 equals m times x minus x1. We're going to plug in for our x and y. When you have 2 points like this, you can choose either one, just like before. But once you make a choice, you have to stick with it. So I see right here, I'm just going to go with -2, 5. Just first point, why not? So when I do that, I get y minus 5, it's my y coordinate, equals, oh, don't know m yet, we'll have to come back for that. But on the inside here, we'll have x minus, it's minus a -2. I'm going to make my life a lot easier and just make this a plus right now. I would combine your double signs and get rid of those before you do the problem. Minus -2 turns into just x plus 2 on the inside here. For my slope, my m, they didn't tell us that in the problem. We're going to have to do delta y over delta x, like in the last problem. It's the same calculation that you've already done, but just really fast. Might as well be thorough. If you find your slope right here, you're going to get -12 over 3, which is -4. So I'm going to plug in -4 right there for my slope. If they give you 2 points, you just find your slope. Not a big deal. And once you get to here, not a bad answer at all, but it's better if y is by itself. So I'm going to distribute, get y minus 5 equals -4x minus 8. You're going to add that 5 to both sides, and you get y equals -4x minus 3. Same answer we got up here on our last problem.